Welcome, and thanks for showing interest in our Master of Mobility and Supply Chain Engineering. My name is Christian Père, and I'm one of the teaching staff members of this Master. In this video, I will explain what you learn in the Master of Mobility and Supply Chain Engineering at KU Leuven, and who can enroll for this Master. But before I do so, I will first say a few words on the domain, Mobility and Supply Chain Engineering itself. Because even though you travel daily and you buy products every day, you may not realize how many engineers work behind the scenes to organize mobility by train, metro, bus, car, shared bikes, and how impressive the network is of boats, terminals, warehouses, trucks, and that supply the resources to manufacture your product and bring it at your doorstep. You can look at transportation systems on different levels where many different players are in complex interaction with each other. We have the level of activities of individuals and their activity chains, but also of companies with their supply chain and distribution strategies. This leads to the desire for moving freight and people and all the choices related to that. Finally, there is the operational level, where there are flows of vehicles and objects and that compete for resources in our physical transportation infrastructures, the roads, the rails, the terminals. Now, what makes it interesting for engineers is that all the components and players in this system are constantly evolving. They develop different production methods, service concepts, economic models, and there is a changing awareness of also the ecological constraints like climate or habitat or biodiversity. Moreover, and that's very interesting for engineers, new technologies trigger constant innovation on all the levels shown in this scheme. In our Master of Mobility and Supply Chain Engineering, we learn to understand this whole range and how to manage and optimize its component using engineering and technology. Because it's indeed technology that drives innovations and new business models that were, for instance, 15 years ago, hardly imaginable. For example, here you see one link in the logistics machine behind world leader in e-commerce, Alibaba. If you click the hyperlink or QR code, you will see how in Alibaba's warehouses, robots and humans collaborate to bring your parcel from China to your doorstep in just a few days. And here's another example where Swiss Post, in this case, as one of the first commercial companies in the world, distributes parcels by drone. For instance, to bring urgent medicine to remote patients, as is the case in this video. But the innovation never stops. Engineers are now transferring the e-commerce technology for moving parcels towards the transport of passengers to offer what they call mobility as a service. It works just like our comic character Lucky Luke, who only has to whistle and then jumps out of the window in blind trust because he knows that by the time he's there, his faithful horse Jolly Jumper will be ready to carry him away from a battle scene. Well, mobility and supply chain engineers are working on apps and more importantly, the logistics behind the scene, such that a virtual whistle from your mobility as a service app triggers a fleet of autonomous taxis that are dispatched to pick you up and drop you off at your next destination. All these examples, they require an optimal system design, flexible operational planning, and optimal real-time dispatching of the supply chain and distribution. And that is why we need specific quantitative mobility and supply chain engineering skills. Because great new technology alone is not enough. The car, for example, also was, and actually still is, a great technological product. But over decades, we have learned how this has not only brought society benefits. A solution that is good for one player in the transportation game can indeed have severe negative consequences for climate or for other people. Mobility and supply chain engineers see this as a game theoretical problem that begs to be designed, managed, and controlled better than we do today. Because just like the car, there exist many mobility and supply chain solutions that work brilliantly for a single user but scale badly and lose their attractiveness if they are not managed sustainably. Indeed, it is brilliant if we can save lives by drone delivery of urgent medicine. And it's sympathetic when, for instance, robotic engineers enable autonomous pizza delivery at our doorstep. But when these services scale, society may not accept for instance, a city that sounds more like a swarm of bees, or will accept that pedestrians are being pushed off the sidewalk by an army of delivery robots? What are the laws that rule such scaling, and how can we use them to our advantage? You see, when the technological feasibility has been proven, that is where the work of you as a mobility and supply chain engineer starts, because it requires good analysis, planning, and optimization skills to let our technological revolutions not turn into this, but rather into an enjoyable city where autonomous taxi pods have been seamlessly integrated with public transport, e-steps, bicycles, and walking. So, mobility and supply chain engineers can make such dreams come true, because it is possible to offer society better mobility and logistics, even though that same society is ever more aware of their social costs and physical impact, and tolerance is less for negative consequences on natural habitat, pollution, climate, and so on. If after your study you don't just want cold technology, but you want to create livable cities and landscapes, to create sustainable and resilient supply chains and efficient distribution networks for our enterprises, and to do all this with respect for human, social, and environmental limitations, well, then mobility and supply chain engineering might be your future. Where our colleague engineers develop the enabling technologies, the mobility and supply chain engineer converts them optimally in what we call intelligent transportation systems, or ITS. We create the added value and businesses with these ITS technologies, and we design and control system-wide solutions that do scale sustainably. Let me make this more tangible and illustrate how one of our mobility and supply chain engineering students did this. In her master thesis, she explored quantitatively how robotaxis could be smartly integrated in the existing regional multimodal system of Leuven. She designed a service network of pickup and drop-off points for passengers and a selection of streets on which early driverless car technology could be allowed, with minimal risk to to bikes and pedestrians, and minimal risk for worsening traffic jams. For this, she modified an existing regional transport model that predicts how many travelers go from A to B in the city of Leuven and which travel modes they prefer. That includes then the newly designed shared taxis, for which she learned the user preference from questionnaires, as of course these services don't exist yet. An efficient tour planning module was then added, marked here in gray, that solves the massive puzzle that decides which passenger is assigned to which vehicle and how these taxis then need to be routed to minimize operational costs and to avoid gridlock. It turned out from her study that thanks to the smart design, the autonomous taxi flows, marked in blue here, would indeed interfere minimally with the existing busy traffic flows that already existed around Leuven, which are shown here in red. Moreover, while similar analysis worldwide warn that cheap robotaxis might mainly be used by former bus passenger and cyclists, our student found that her smart design would rather compete with car instead of cannibalizing sustainable modes, because the robotaxi service design targets trips around the city, where the car used to be dominant. And bus lines are more used for radial trips in and out of the city center, where, on purpose, the service was not offered. This kind of quantitative predictions can help end users, but also businesses, infrastructure operators, and governments to take position in the debate on how autonomous driving and other technologies like 3D printing, artificial intelligence could or should be deployed in our mobility and supply chain networks. Our engineers will analyze data and how new transportation technologies are being used and what their impact is on various stakeholders. They can tell how the design, coordination, and control can be further improved and continuously optimized. So, how do those ambitions translate into the study program of our master? Foremost, we further develop all your mathematical analytical skills from the bachelor's. we build up a quantitative toolkit that puts you in a position to optimize supply chain and traffic processes. For instance, this entails coding, data science, geographical information system, management techniques, game theory, modeling, optimizations, and operations research. Next, we have two domain-specific learning lines. The first one takes the perspective of a single user or company. So here, you study logistics, supply chain engineering, operations research that support this perspective. The other line is a complementary perspective of the collective or system point of view. Here you study network modeling, public transport design, transportation system design and control. And finally, you can of course not detach all this hardcore engineering from its social and corporate contexts. And that is why you also study transport economics, safety, ergonomics, industrial management. This can be found back in the structure of our master here. On top in orange, you see some courses building up that quantitative toolkit. To the right in blue, you see the learning line from the user and company perspective. The left in yellow is the collective system perspective learning line. In the middle is where this all meets in the socioeconomic and spatial context. If you want more details on any of these courses, feel free to scan the QR or click the link to our website and the online program book that can be found there. Now, who can enroll in this master? If you are an international student, I refer you to the faculty rules for requirements on language and transferability of your non-EU engineering degree. If you are an EU student, and so especially KU Leuven bachelor students, for instance, know that any bachelor or master of engineering can enroll, even though some disciplines are of course more relevant to mobility and supply chain engineering than others. For instance, computer science, mechanical engineering, civil engineering, or industrial engineering. But in fact, the analytical background from any bachelor should have you prepared for a master's. So, with this, I conclude this introduction. Feel free to visit our website and ask any of the staff, including myself or my colleagues Peter, Johan, and Lilian. And who knows, see each other in the future. Bye.